Okay, so this is the second lesson in solving quadratic equations by the most efficient method, either by taking square roots, completing the square of the quadratic formula, or factoring. In lesson 1, we spent a little bit of time examining the structure of our quadratic equations and then deciding what method to apply. We're going to spend a lot more time today practicing that. So if everyone could please turn to page 11 in your packet and examine Lucy and Gary's work. So you'll notice that Lucy, she's got 2 solutions and Gary's only got 1. Why is that? And well, the reason is that Gary went to math jail. Sorry, Gary, you went to math jail. Boo-hoo for you. Right here, you'll notice that we've got 3x minus 2 squared, and here's our other 3x minus 2, and then in this line, oh, it's missing! So from here to here, Gary divided by 3, oops, what's going on there? Hey, let's try it here. He divided by 3x minus 2, there we go. And by doing that, he lost the solution of 2/3. He does not have that solution in his solution set. So sad, Gary. So the answer is, Lucy is correct. Gary divided by 3x minus 2. He lost the solution 2/3 because he divided by a variable and he will go to math jail. Sorry, Gary. Here are the answers to last night's homework. They were on Classroom last night, so you should be familiar with them. If you need to pause the video and take another look at those, go ahead. Okay, so one of the things that I feel is important for every Algebra 2 student to see is how the quadratic formula comes to be. So this is going to be a just watch. I'm going to derive for you the quadratic formula by completing the square. So the first thing I'm going to do is I'm going to isolate 1x squared plus bx. I'm going to do that by subtracting c. That's supposed to be a c. I'm going to divide by a. So now I've got 1x squared plus b over ax equals negative c over a. Now I need to do b over 2 squared, but instead of b, I have b over a. So I'm going to say b over a is my b. I need to divide that by 2 and square it. So that's like b over a times 1/2 squared, which is like b over 2a squared, which is b squared over 4a squared. So if I took b that I highlighted, divided it by 2 and squared it, this is what I would get. So that's what I'm going to add to both sides. So I'm going to have x squared. This side of the slate is not behaving, so we might have to move over here. So we're going to have x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. And you'll see I left some space here, and that was not like an active slate weirdness. That was on purpose because I want to be able to add these together. I know, crazy, right? Common denominators. If this is a and this is 4a squared, I need another 4a. So this becomes negative 4ac over 4a squared plus b squared over 4ac. And just because this one's negative and this one's positive, I'm going to write this as b squared minus 4ac. That's a squared. I don't know what happened with what that's all about. All over 4a squared. Now you should see this right side is starting to look familiar. So let's work on the left side for a little bit. We've created this perfect square trinomial, and what adds to b over a and multiplies to b squared over 4a squared is simply b over 2a. If I multiplied b over 2a times b over 2a, I would get b squared over 4a squared. If I added these together, b over 2a plus b over, 2a, that would be 2b over 2a, which is just b over a. So that's how we have now rewritten our perfect square trinomial as a binomial squared. We'll put it down here also. We slide this down to where the active slate is feeling cooperative. Again, you are just watching. I would never make you do this on your own, but it is important to see how this develops. I'm going to take the square root of both sides. That's going to give me x plus b over 2a equals plus or minus the square root of b squared minus 4ac. Now, what is the square root of 4? It is 2. What is the square root of a squared? It is a. OMG, we're almost done! If we subtract b over 2a from both sides, hey look, we already have common denominators, that's a bonus. We have now derived, that's a bad looking x, the quadratic formula. Whoop. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Ta-da. The quadratic formula comes from completing the square. Now that we have that, let's take a look at page 13. So what I'd like you to do on page 13 is I would like you to pause the video and examine these problems and find out if they are done correctly. If they are done correctly, write no errors. If there is an error, please identify what that error is. Okay, I'm assuming that you have now had a chance to look at them. If we take a look at number 1, we see indeed there is an error right here. This x, it appears they've divided both sides by x, and that's sad because x equals 0 is also a solution. Number 2 is also done incorrectly because they didn't really apply the zero product property. It should be x equals -5 and x equals 3. When we take a look at this problem, let's see, check. We are missing the plus or minus at the very end. That should be plus or minus. And you can totally write, that would be okay to write the square root of 28. That would be fine. Over here, number 4 is done correctly. So now we are asked to solve with the quadratic formula. So right here at the very beginning, we have an error. This is not negative b. This should be a positive 7. So if I make this a positive 7, I have 7 plus 11 over 6. So 7 plus 11 is 18, divided by 6 would be positive 3. And then 7 minus 11 over 6, well 7 minus 11 would be negative 4. Negative 4 over 3 would be negative 4 over 6 would be negative 2/3. And then looking over here, oh, right away, that's not the bell for you. Right away, they've got it equal to 2, and it should be equal to 0. So the whole thing, sadly, is wrong. And they needed to write this as 2x squared plus 4x minus 10 equals 0. And to be honest with you, I don't know that I would solve with this with the quadratic formula. It just does not seem efficient. I think I might start by factoring or dividing by 2. I'm allowed to divide by 2 because 2 is a constant, not a variable. And now I see I've got 1x squared plus 2x, and I'm a renegade, and even though it says solve by the quadratic formula, I know that it's faster to solve using completing the square. So I'm going to add the 5, and then I've got my b value here is 2. 2 divided by 2 squared, 2 over 2, so let me write that down, 2 over 2, that's just 1, so I'm just going to add 1 to both sides. Now I've got x plus 1 squared equals 6. And my final answer, take the square root of both sides, plus or minus the square root of 6. Boom. The end. Happy birthday to us. Alright, what I would like you to do now, on pages 15 and 16 of your packet, there are like 10 problems. I want you to work on those 10 problems and solve them using the most efficient method. Then feel free to unpause the video and come back and check them. So, go ahead and work. I'm assuming you have completed these on your own and you are ready to see the solutions. So, the fun thing is that the first 4 problems here, all 4 of them, they all solve just with square roots. They're really easy problems. That's terrible writing. If I take the square root of both sides, I get t equals plus or minus 7, the end. If I take the square root of both sides, I just get r equals 0. Easy po-peasy. For this one, I'm going to divide both sides by 3. I've got a squared equals 4/3. I'm going to take the square root of both sides. I get plus or minus the square root of 4/3, which becomes plus or minus 2 over root 3, which offends my eyes. So I'm going to multiply by root 3 over root 3, and I get a equals plus or minus 2 root 3 over 3. For this 4th problem, I'm going to start by multiplying both sides by 2. I get y squared equals 2/5, and then this problem is exactly like its next door neighbor. I go and take the square root of both sides, and well, close, but there's no perfect square. And I get plus or minus the square root of 2/5. And again, that's like plus or minus the square root of 2 over the square root of 5. I don't want a radical in the denominator. It's like bad math grammar. So I'm going to multiply by root 5 over root 5 because that would give me the square root of 25. So that's like the square root of 10 over the square root of 25. So that gives us y equals plus or minus the square root of 10 over 5. All right. Yay, another square roots question. Easy peasy. X equals plus or minus the square root of 7. Now I have a challenge. I look at this last problem on page 15 and I'm like, I'm not using square roots. So the next question I want to ask myself after I notice that square roots is not obvious is, does it factor? Can you find 2 numbers that add to -8 and multiply to 15? Why, indeed you can. Factoring is the most efficient method of solving this problem. Any other method is considered inefficient. Why is this important? We are efficient mathematicians, and you are going to be so efficient on your exit ticket that you will only be allowed to use each method 1 time, which means you need to look at the problem and recognize this problem is for factoring. If you waste your quadratic formula on this problem, you will not have it available to you for the problem that actually requires the quadratic formula. That's not your bell. On page 16, now we've got some trickiness. So I look at this and I'm going to try to factor it. And the reason I'm going to try to factor it is because I immediately notice that it has a constant that can be divided out of 2. A constant, not a variable, ladies and gentlemen. We never divide by a variable or we would go to math jail. And now, are there 2 numbers that add to -8 and multiply to, this is the same problem as the last one. Alright, so this is a little complicated, and I noticed that it is not in standard form. So the first thing I gotta do is get this in standard form. I also noticed that it has this pesky 3/4 here, and you all hate fractions, so let's just kill it by multiplying both sides by 4. If we do that, I only need to multiply the 4 to the coefficient here because this is a product. So I've got 3c times c minus 1 equals 4c. Now I'm going to distribute 3c squared minus 3c equals 4c. I'm going to collect everything on the left side to get it in standard form so I can better examine it. And I get 3c squared minus 7c equals 0. Now I'm ready to make a decision. What is the best method to solve this? If you said greatest common factor, you are correct. We're going to take out a c. We're going to be left with 3c minus 7. The first factor, c, will give us a solution of c equals 0. And the second factor, 3c minus 7, gives us a solution of 7/3. Okay. Again, before I attempt anything, I got to get it in standard form. And it just makes sense to move everything to the right because the p squared is there and he's kind of like the boss. So I've got 0 equals p squared minus 2p plus 1. So this was factor a equals 1. This was GCF, but also factor. So now I look at this guy again. Obviously, I'm not using square roots. Can I factor it? Yes, I can. Again, yay! What adds to -2 and multiplies to 1? -1 and -1. So I don't need to write it twice. P equals 1. Alright. I'm gonna move on. That guy he scares me. I'm gonna go to the one underneath because he looks cuter. T squared equals 4t. I'm not gonna divide by t, even though both sides have a t, because that would lose a solution and I would go to math jail. I'm gonna subtract 4t from both sides. Now, after I subtract 4t from both sides, I see that this is a greatest common factor situation. I'm going to take out a t, and my two solutions are t equals 0 and t equals 4. Now, this last guy, he's a little creepy. That's a 7. That's a 5. That's a 3. I don't think that you can use square roots, and I'm definitely not going to start completing the square because this is like all odd numbers. So real quick, I'm going to do a factoring check. I'm going to do 7 times -3, which is -21. And I'm going to think to myself, are there any numbers that add to 5 that multiply to -21? No, there aren't. So I cannot factor this one. Now it's time to pull out the quadratic formula because I've exhausted all my other possibilities. Only once all my other possibilities are exhausted do I go to the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. If you have not memorized the quadratic formula, you need to get on that right away. So I've got -5 plus or minus the square root of 109 over 14. The end. It's a really long square root, so it's kind of creeping me out. All right, ladies and gentlemen, your homework tonight is to complete the Explore More numbers 1 to 12, and please make sure you are using the most efficient method. I do have all the solutions for you, and I will display them.